we're going to present how useful mathematics is in our daily lives, especially number theory and its concepts, which are divisibility, congruence, and arithmetic functions. So, without further ado, let's start the ball rolling. Let us first discuss what number theory is. Number theory is the branch of mathematics that studies integers, which are all the whole numbers on the other side of the number line. It looks at specific properties of integers and seeks patterns in the ways different types of numbers are distributed or related to each other. The best known application of number theory is public key cryptography. Have you heard about this before? If not, let me tell you what it is. Cryptography is a method of protecting informations and communications through the use of codes, so that only those for whom the information is intended can read and process it. The prefix crypt means hidden or bold, and the suffix graphy stands for writing. But wait, there's more. In addition to cryptography, number theory has been applied to other areas such as error-correcting codes, numerical integration, computer arithmetic, random and quasi-random number generation.
Number theory is still useful in our lives. Now, let's continue discussing one of its concepts, the divisibility. Here's the definition of divisibility. If A and B are integers, and there is some integer C, such that A is equal to B times C, where A and B can be any integer, but C has to be a positive integer. Then, we say that B divides A, or B is a factor or divisor of A. Then we write B divides A. But what do we mean by that? It simply means divisibility rules are tools that help you know quickly if a number is divisible by a certain integer.
The following are few sample rules.
Did you know that divisibility rules are useful in our life? How? Let me give you a very common example.
Divisibility rules can be used in everyday life. For example, if you're at a grocery store and need to find which deal is better using divisibility rules. Let's say 2 cans of beans cost $6, while in another store, 4 cans of beans cost $8. Which deal is better? We know that 6 is divisible by 2, so each can costs $3. We also know that 8 is divisible by 4, so meaning each can costs $2. Now, we know that the store with 4 cans which cost $8 is the best deal. Can you now see how important divisibility is? There's a lot more uses of divisibility, and we are actually using its concepts without us noticing it.
We are done with the first concept, so let us proceed to the second one, which is congruence. Proceed to the second one, which is congruence. Congruence is an important part and useful tool for the study of divisibility. As we shall see, they are also critical in the art of cryptography. Here is the definition of congruence. If A and B are integers and n is less than 0, we write A is congruent to B modulo n, to mean n is divided by the difference of B and A. We read this as A is congruent to B modulo n. For example, 29 is congruent to 8 modulo 7 and 60 is congruent to 0 modulo 15. We can apply the congruence in the days of a week using the Gregorian calendar. Let the days of the week be represented by the following numbers. Also, let the months of a year be represented by the numbers. We can express each data using the following variables. Using the Gregorian calendar, and the above conventions are given, where W is the day of the week, of the date K, of the month M, of year N.
We are now down to the last concept, which is the arithmetic function. An arithmetic function is a function defined in the positive integers, which takes values in a real or complex numbers. Many functions which are important in number theory are arithmetic functions.
The Euler-5 function is an arithmetic function.
Functions are everywhere where technology is, literally. But since the world is not crazy about machine learning, let me mention this one. Machine learning is all about learning a function.
Mathematicians have long been working on function estimation or approximation. Taylor or Fourier analysis is one example. What makes machines or statistical learning different from classical approaches is that we are now using new models for the functions. Next is approximations is based on collected data rather than on intrinsic functional property. Next is new efficient optimization algorithms are used to fit the data to the model. It is pertinent to note how one experiences mathematical applications in daily life, from the time gets up to bed till one goes to bed at night.
Be it a cook or a farmer, a carpenter, a mechanic, a shopkeeper or a doctor, an engineer or a scientist, a musician or a magician, an artist or a tailor. Everyone needs math in daily life. That would be all for today. I hope you appreciate mathematics more and learn something from our report. This is Arian Mayor Pumarca.
This is Crisandra Gabriel C. Pajares.
This is Eleazar Loteria.
Thank you, and let's be all safe.